Alright, so we're going to be doing 6-7 polynomial long division. So, if you think back in the day, when you learned a long division in general, hopefully you still remember it, because if you don't, then you might have a little bit more trouble doing this, but I'm so nice enough to show you how regular long division is. I'm going to be reminding you how to do it, so we're going to go over that before we go over the new material of polynomial long division. Again, they're basically the same concept, but obviously one has just numbers and one actually has polynomials in it. So, for regular long division, so if we are trying to divide 949 divided by 23, we're going to set it up like this. I'm going to write it in this color. I'm going to do a bunch of color changes. So I'm going to put, of course it did not do that right color. Okay, so we're going to do 949 divided by 23. That's how you write it. So you write the top part of the fraction inside and the bottom one outside, okay? So, now we're going to think about it, and okay, so we need to look, since this is a 23 right there, it can't go into 9, so we have to look at the 94. So we're going to look at just the first two digits. We're going to ignore that last 9. So how many times does 23 go into 94? Well, I know 20 goes, obviously you can use a calculator if you want, but I'm thinking, and you got to figure out the most times. So I'm thinking, well, I know 20 times 4 is 80, and then 3 times 4 is 12, so that would still be under 94, so that would be perfect. So it's gonna be able to go in 4 times at the most. So 4 times 3 is 12, so carry that 1. 4 times 2 is 8, 9, so 92, so I'm left with a remainder of 2. So I need to bring down the 9, and now how many times does 23 go into 29? Once. So 1 times 23 is 23. Subtract, and we get 6. So there's nothing left, and we're not going to keep going with decimals, so we're just going to be left with, this is our remainder. And we could just say 41 remainder 6, but that's not how we're going to write it. I want to write it as a mixed number. So I'm going to say I have 40, it goes into it 41 times, but we're going to have 6 over 23 left over, because 6 cannot be divided by 23. So that is my answer. So it can be written as 41 and 6/23 in that mixed number, or you can also think about it as 41 plus 6 2/3, because we did talk about how mixed numbers and fractions, or mixed numbers is just, you know, the number plus the fraction. So we can write it like this. So keep this in mind as we go on to our polynomial long division. So, same kind of concept in the sense that the top part is going to go inside, so I'm going to write 8x squared plus 6x plus 3. I'm going to write it inside, and then I'm going to have the 4x plus 1 on the outside. So now it's a little bit different in the sense of how we're figuring it out. We actually, again, we're going to be looking at the first part, like you see that 4x, the first term, there we go, to see what we need to multiply. So I'm looking at this first term and this first term right here. So I need to know what times 4x will give me 8x squared. Hopefully you're like, Miss Robinson, that is 2x. So I'm going to write 2x, and I'm going to write it above the 6x because it's the same kind of power. So I'm going to line that up. So 2x, and now I need to multiply, okay? Just kind of like what we did before. So I need to multiply 2x times that first term, which is 4x. So 2x times 4x is 8x squared, and that's good because that's what we wanted to have here, because then it'll cancel out later. But then I need to multiply 2x times the second term right here, which is 1. So 2x times 1 is 2x. So now, once we have this, if you look back up here, we would subtract every time. So like we would have to subtract it. So that's the same thing we're going to have to do here. We're going to have to subtract, but when we're subtracting, we have to distribute the negative. So those are both going to be changed to negative. And then 8x squared minus 8x squared is canceled out, and then 6x minus 2x is 4x. So that's going to bring down that plus 3. And now I need to think, what times 4x is 4x? Hopefully you're saying, Miss Robinson, that's 1, so I'm going to put plus 1. 1 times 4x is 4x. and 1 times 1 is 1, and then we need to subtract, so change those signs, and those cancel, and we're left 3 minus 1, which is 2, and again, we can't go any more, because nothing times 4x, well, there is something, but it would be a fraction, so that's how we're going to write this remainder. But like, once we have that, we go all the way to the end, you see how with the end there, that's our remainder. So, the way we write our remainder, just like if we looked above here, it's 6 over 23, we took the remainder and we divided it by what our divisor, this is called a divisor, so whatever's on the outside. So I'm going to have plus, oops, no, I didn't want that color, plus, oh, that's going to bother me, plus 2 over, and we use this 4x plus 1. And that is our answer. Okay? So again, you might feel a little worried. It's definitely important that you follow these steps and you're not just copying down, just looking at this and then just copying that down, because you got to do it in the correct order in the motions. Okay, so we're going to divide, so we know that we need to put the top one on the inside, but I want to put it in order from x squared down to the x, then just the number, okay? So it's descending power order. So I'm going to write 15x squared first, and then I'm going to put plus 34x minus 16. And then I got to put 5x minus 2 out on the top. So I need to think, what times 5x will give me 15x squared? That's 3x. So I'm going to put the 3x right here above the 34x. So 3x times 5x is 15x squared. 3x times negative 2 is a negative 6x. Okay? So again, now we need to subtract, so we're going to change those signs, and we cancel that out. So then we get 34x plus 6x is 40x. Bring down the negative 16. And we think, what times 5x will give me 40x? That's just a positive 8. So positive 8 times 5x is 40x. Positive 8 times a negative 2 is a negative 16. Need to subtract, so I change the signs. So that cancels, so I'm left with a remainder of 0. So if you're left with a remainder of 0, then you don't have, or then you don't, actually a 0. You don't have a remainder. So your answer is going to be just what's up here, which in this case is 3x plus 8. Okay, one more example. Hopefully you're starting to get used to it. Okay, so this is a special case in a sense that we need to account for every single power in descending order. What I mean by that is, we know that 2a cubed plus 5 is going to go on the inside. Well, I need to write 2a cubed, but I need to account for every single power, so like a squared and a. Well, we don't have any of those. So the way we're going to write it, and it's not letting me write, okay, plus we're going to write 0a squared, because we don't have any. That still equals 0. But we need to have that as a placeholder. So then we're going to put plus 0a and plus 5. So this means the same thing. So this means the same thing as this up here. But you have to have the placeholders for the long division. So we're going to have a minus 3. Again, same thing. So what times a will give me 2a cubed? That will be a 2a squared. So 2a squared times a is 2a cubed. Now 2a squared times a negative 3 is a negative 6a squared. So if you notice, the reason why we have those placeholders is because we need to add like terms, so that's why, and we can add a squared and a squared. So that's why we have that placeholder. So we need to subtract, so change those signs, so that cancels out. So 0a squared plus 6a squared is 6a squared. Now bring down that 0a, and we go, what times a will give me 6a squared? That's a 6a. So 6a times a is 6a squared. 6a times a negative 3 is a negative 18a. And we need to change the signs because we're subtracting, cancel. So that's going to be 18a. Bring down the 5. So we have, oh, I didn't want to write it in red. Oh, it's okay. So then, what times a gives me 18a? That's a positive 18. So 18 times a is 18a. And 18 times a negative 3 is a positive 54. Got to change the sign, so negative, negative. So therefore that cancels. And then 5 minus 54. Did I copy something down wrong? Because I'm looking at my notes. Oh, I must have done something. Hold on. Got it. I figured it out. It's supposed to be, for originally 18 times a negative 3 should be a negative 54, but then when I change the signs, it's going to be positive, so then we add them, and we get 59. So therefore that's our remainder, so we're going to be adding 59 over whatever this is over here, the divisor, a minus 3. And we have our answer. There you have it.